Hey everybody, this is Larry. This is Leetcode Weekly Contest 413. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, these problems, everything in between. This is the live recording of the video. Each problem will have its own video in its own... Each problem will have its own video, alright? So definitely check that out. I just finished running 8 miles or something like this, so I'm a little bit just catching up or whatever, but yeah, that's as they say. Let's go. 18 seconds. Wish me luck. I did okay on the morning contest or the bi-weekly. For me, it's the morning. I know some of y'all, it's like the day before, but hopefully I keep that, doing well alive. Now we're at 4 seconds. 3, 2, 1. Go, go, go. Oh, that was loaded fast. All right, we have a 6 and a 7 this time. Okay, so then that's not right, of course. It's not the true way, but it's actually just mod too. I should have to have a helper there. Okay. Cave nearest obstacle from the origin. Okay. Cave nearest. So then now we have further away. So I mean it's a heap problem, but oh, it's x plus y, huh? So then do we want a min heap or max heap? Why am I so bad at this? Maybe I'm wrong on this one actually. So the values of this. So just one from each one, right? 10 by 10. One from each row, so it's either 8, 7, or 8, 7, 8. This is a hard problem. Did anyone solve this one? No. By 10. Well, there are only 9 numbers, but is it always possible? I guess it's no. No, I guess it's always possible because you don't need to. You could have more rows than columns. Okay. You don't need to select from every row. Is it sorting? Is it greedy? How do you choose, for example, how do you choose which one to go? No one's gotten it yet, which is, I guess, good. Okay, so 10 by 10. So the answer is at most 1,000, less than that really, but can I? The uniqueness is kind of weird. Okay, let's say they're all identical, right? Then now it's going to choose one. That means by definition we've okay. The row thing is a confusing thing. So it's a DP on. Is it a DP, Larry? Okay, and reverse. Okay, so then now we want to Okay, there's a bit mask for each row. And a maximum value that the last value, and we select from that, right? It's a little bit wonky, but a 100 times 1,000 should be fine, but we have to be careful about this one, I think. 'Do like a reverse binary search or something. I want to do a lookup. That's what I want to do. Okay, fine. So then now for each row, we have a lookup. Okay. Now for people, guys, so far 6 people. I think I'm on the right track. We'll see. So that now no. We want to see 4K in range of 1. We want to see the next number or the first index in which it is bigger than this one, right? If grid of I K is so if the max is this, we want to see the next number that is smaller than it. So if, this is if this number is no, so yeah. So okay. What? Okay, this is right. So then now if we have 0, if 0 is the max, then 2 is the max, then we get okay. What? 4 is okay, yeah, I think this is right. It's so easy to get off by 1 is why. Okay, so then now we want index 0 lookup. Oops. Okay. Right. I need 101. Okay, and then now it is present. Last is going to be quit sub I of index. This our bound over. Oh, because this is n. Yeah, okay. Yeah. Eight and 15. I want to make sure that we. Looks okay. Is it fast enough? I don't know. Let's try a real quick one. Oh, this is definitely wrong because oh no, I do keep track of here, so I think that's right. Okay, fine. I know I'm spending time on this. I probably don't need to. I probably should YOLO this, but just want to see about the timing. That's not a great sign though. Oh no, it's 10 by 10, not 100 by 100. So okay, so maybe it still could be a good sign, but let's see. Okay, yeah, that's fast enough for 10 by 10. Okay, YOLO. Okay, thank you, sir. 25 people got it. How many people got this one? 3. So we're doing good time, but let's take a look. Maximum XO score of any subarray. It's a sick tree problem. If it is, people have gotten it, I feel like. N is 2000. No, because you can't. Can you merge on the left side, right side? No. I don't know. I mean, N square is barely out of reach, otherwise people have gotten it, I guess. But 284 is 12. N square is 4 million though. I'm just curious why this N. 4 million is not fast enough, clearly, but or shouldn't be. Otherwise, this is a very dumb problem. 4 million over 2, so it's like 2 million. Maybe it's out of memory. This is such a weird constraint. I don't know what to do with it yet. Can we do prefix sum? Yeah, I guess so, right? No. Well. So okay, so you have a set of values and then you well, no, because there's any subarray of that bound, right? Anyone get all 4 yet? Oh, I guess so. Wow. Oh no, that's. Oh yeah. Wow. Congrats. Can you combine? Is it square root decomposition? There's a lot of things though. Yeah, even if there are a lot of queries, so you have to answer queries in log n pretty much. So no chance that it is square root decomp, which then it just becomes square root of n, which even then is too slow. So it has to be log n pretty much, or 1. I don't know how to do it without like it just straight up being 4 million queries. Maybe we can do it a little bit smarter, but that's the thing about these problems, is that like these constraints mean nothing because Leetcode's very inconsistent about how, like, it's still guesswork, right? Did people get wrong answers on this one? No, at least not those 2 people. That is incredibly fast. 5 minutes. I'm almost hesitate to think like. Can I do binary search? Not really. Can I do? And people are getting it, but I don't know why n squared wouldn't be fast enough, but oh no, it's because then now you have to. Okay, so the n squared, I see. I misread this one again. N squared, so now it's not just 0 to 3. That is easy to do with prefix sum anyway. It is every possible subset in the queries that you have to understand. Okay. I feel got it really fast. Kind of impressed actually. But the thing with XOR is that, what is the thing with XOR, Larry? It's that it is not monotonically increasing or decreasing. So that makes it a little bit weird. Can we process the queries backwards? We definitely can. Update them with 1 element. But even that's a little bit sketch, right? But we have an hour and 7 minutes. Can I focus long enough to do it? I don't know. Wait. Did I misunderstand this? Okay, let me actually. Okay, do the XOR score of an array is by repeating upon, so that only 1 element returns. This isn't quite. This is a weird XOR query, right? Simultaneously replace a sub I with x for all indexes except for the last one. Two x. Wait, maybe I didn't even read this problem correctly. The XOR of an array simultaneously we play for all indexes I. Wait, what? Okay, this isn't just getting the XOR of them, right? Then okay. Let's say we right, 7, 3, 2, 8, right? So then now after one iteration, what does that mean? Okay, maybe then I have something here, or at least I have something to analyze, right? So okay. So then now iteration for I. While length array is greater than 0 or greater than 1, I suppose. Okay, and then now new array, right? So then for I in range of length of array, we replace it with, and this is -1, I suppose, array of I plus 1, right? And then array is equal to new array, right? And then we can print array, right? Let's analyze this real quick. It's 14, which is what they tell you. That's good. And here we calc, right? But I'm interested in mode evolution. So here we could do this, right? Did I not print stuff? Oh, I didn't run it because okay. So then 14. That's not the same as. I mean, I don't know what it should be anyway, but that's not the same as. That's not the same as this, right? Or this. It's such a weird way of phrasing it, though, right? Or am I just being crazy? I mean, could be both, honestly. Okay, so then, what a weird definition that they give you. But okay, I mean, maybe it's a thing, right? Because this is 4 digits. What if there's 5? Is that right? It's the same. Well, maybe that's just a weird definition. I don't know why they have this definition though. But okay. Alright, Larry. Am I wrong? Or maybe I was just putting the one. Okay, so they're definitely different than just XORing the entire subsection, right? So this score does something funky. So we have to analyze this function. I totally skipped over it because I didn't know what they were asking for, honestly. It's kind of a weird thing. Okay. Alright. Now we have something interesting to do. I misread this, but okay. And it's probably something like XORing 2 numbers or something weird. I don't know. How do I think about this? What does 11 mean to me? Okay, let's write it out. So then now, after one iteration, okay, I'll just type it out. I'm writing out too slowly. So okay, so then we start with something like this. And then after one iteration, we have something like this. And we remove the last number, right? So then now, I feel like this reminds me of a problem actually. So then now we XOR these two, right? So because we XOR that, and then x1, and of course this eliminates. So then now we have these things, right? And then yeah, I mean, and then you just say a4, a3, a5, and then you kind of am I doing this right? Maybe that didn't generalize as I hoped. A1, and then you XOR it with A1 and A2, right? And then the next one's gonna be A1, A2, 2. I mean, I know that that cancels out. A2, A4, I know I'm doing it really like stupidly, but maybe I need this to help. And then now we do this with this, right? A1 and A1's cancel out, so okay, so it does cancel out, so it doesn't cancel out as much as I would like, but A1, A2, A3, right? And then now these two, it's going to be A1, A2, A3, A4, and then the other one's going to maybe I should copy and paste a little bit, right? And then now you do these two, and then now it will be, and all of them cancels out except for this, and then all of these cancels out except for these, right? Am I doing this right? I think so, but then, and then now it's A4 to A1, A5, right? Is that right for a 6 number thing? We could try it. So we have 1, 2, 4, 8, 16, 32. So if this is right, we should have 4 digits. I don't know what that should be. 63 is definitely, oh, this is the X. Okay, that's right. 51. What's 51? 51 is 63 minus 12, so minus the 4 and the 8. So it's 0, 1, 4, and 5, which is what we expect. Okay, but then how do we generalize this? A lot of people are getting it, so smart people. Not even on the first page. Okay, so it's not the XOR this thing. So okay, we don't have to care about this thing as much because apparently it is not right anyway. So then now we have 51. Okay. Then we have this thing, which is right and true. Right, so then now we have to try to max. Okay, so for 6 digits you skip the middle. I mean, we could do prefix sums about it, but I don't know. Okay, if it's 2 numbers, okay, if it's 1 number it's just this, if it's 2 numbers it's this, if it's 3 numbers then we have just this, right? I think this is right. Just kind of ignore these things. So yeah, and then you have 4 numbers, it becomes this, which is kind of nuts. Is that true? We have 4 numbers. it would be, what's that? 15. It is 15. Okay, so that's true. Huh. Do we have to calculate these bit masks for every... That's great. Okay, so it's two numbers that are one space ahead or subset of two, and then four numbers, okay, and then 5 numbers is going to be this. 6 numbers is this for some reason. Right. I don't know that I see a pattern, but so okay, so 32, 64. So that's for 7 numbers. 7 numbers, we have every other number. Man, so the pattern goes from 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0. Is this right? For 5 numbers? Let's try. I thought we did it though, right? So for 5 numbers, it is... Yeah, okay. It just looks a little different. And then for 6 numbers, is this for some reason, right? Okay, so then now maybe we'll just put this in a for loop, right? So I don't have to kind of manually do this, right? For I in range of, I don't know, 20, say, right? Like this. Do I see a pattern? I mean, this, I guess, but this is such a... I don't know what to do with this pattern, honestly. Right? I know that it has less than 20 whatever, but... And also, why not? So, is this helpful at all? This looks actually like whatchamacallit triangle. But I don't know how I'm going to use this to help. Three people's gotten it though, so apparently. There's a special name for this triangle. It's actually kind of cool, but I don't know what to do about this though. 4 in a row. Also, what does this mean? That means that has the contribution, and all the zeros means that they cancel out. And of course, it doesn't mean anything in terms of, I don't know. I mean, we could draw it more, but I don't see enough of it. Like, I see the pattern, but I don't know how to pre-process it. It's actually a very cool pattern, but like Serpini's triangle or something. But I don't know what to do with it. Because we have to find, it's not even that we have to find the XOR score of this, which is already, actually that would have been pretty okay, but Yeah, we could find. I mean, given this pattern, I guess we can figure out a pattern to figure this out, but it still doesn't mean anything for me. So okay, so the max number is fine, but then now you have these things that max to 14. How do you even get 14? Like how do I figure out that this, so 4 numbers, but 4 numbers is, I guess, all 4, but how do I even get that? But yeah, I might go make this bigger, but it just prints more things, which is not super useful. Like how do I look at this and be like, oh, yep, that's the ideal. I mean, okay, 1 is 1, 2 is 2. Like, is there a thing where like the answer is always 2 numbers or something? Probably not, right? Because you could create one with 4 numbers. Okay, let's actually look at the constraints. No, the numbers that goes up to 2 to the 33 plus 1, or whatever. I said it wrong. Whatever. Which means that the only okay. That was an int. Oh my god. Okay. And 16, and I assume 32 is good. So every power of 2 we have the thing. And what are these, and then it's just like 8 and then combine. Can we do a combination, like a bind? But then what about this part, right? How do you merge these things? I mean, I know that this is just like 1 0 1 0 and then merge, but man, people are smart. A lot of people got it though. I have no idea. No idea at all. I mean, I see a pattern of the XOR. Okay, so it's either 1 number or 2 numbers. Is that always the answer? No, because as I said, okay, you have 4 numbers. You construct a case of 4 numbers, construct a case of 8 numbers, but you cannot construct a case of 7 numbers. But then you could do. Can I do? And also like 1 and 5 is weird, or 1 and 4. Oh, 0 and 4, 1 and 5. So you skip 3. How do you even model that, right? I mean, yes, you can. Can I do this and then this? So this. I see. I mean, I guess I see it, right? Because then now you get 1 number, and then you merge, so then now you have 2, and then you do it again, you have 3. So then you have an n square type thing of max things, right? I see. I don't know if n square is fast enough though, but I see. So you just do them all at the same time pre-calc, right? Yeah, and then you just do an RMQ on that, which is fine, right? because then now, so this is just, yeah, so then, okay, I see. Okay. Well, I'm just gonna, I don't think that's the right name for it, but that's fine. Whatever. And now, and then now for the, yeah, that's not right. I'm missing a thingy. It goes up to n minus I suppose. Is that right? Oh, did I think I met, no, this is from something else. Okay. What I want is we print answer. Okay, so this is that the input? That is the input, the powers of 2s. I actually didn't realize that. Okay, so then that's 1, and then that's 2, right? Is that right though? Yeah, let's yeah, so let's try it then. I don't know if this is true. Oops. Okay, that is it. So it goes from I to J. This is not from I to J. This is starting at J after I iterations, right? Okay, so what does this mean here? You could get it, Larry, I think. Okay. What does this answer mean? Starting at J after I iterations. So that means that we want J minus I and starting at I. Okay, so that means that, so now we got this. Okay, that means that we pre-calculate correctly, right? And we could even just do, just for the funds. I think I did the wrong in the other one too. What is it? 2000? Oops. I mean, it's going to be n squared, that's fine. Maybe it's a little bit too slow. Also, we print too much, maybe. No, we only print one thing. But, alright, maybe that's too slow for here. Just because we do this thing. So, I think if we don't do this thing, it's probably fine. Let's just do a random thing that's much smaller. It also means that it is mostly correct, because if it's not, then the assertion would have been wrong a long time ago, right? Okay, so 100 works, so that means that this is now giving us the answer. So then now we just have to get the max. So within the query, then now we do RMQ, right? So we have sparse table. I'm gonna We don't even need to, right? Actually, I mean we can, but so j is after I iterations. So okay, so R is equal to okay, right? We don't need this anymore. How do I? What does this mean? What is ij, Larry? Ij is j is starting at j after I combinations. Okay, so then now what does that mean? That means that best of j, best of jj is going to be after 0, right? Iteration. Okay, so let's do this first, right? No negative numbers, right? Because that doesn't make sense. All right, this is not needed anymore. Okay, and then now we have to combine these after one iteration. Okay, so if I is 1, that means that is j and j plus 1, right? So j and j plus I is equal to best of j plus I minus 1. So that's the way it used to be, starting at j. Or answer sub ij, and then now for each query, for SE and queries, I called the other thing the answer, so it's a little bit confusing. Best of SE, and hopefully we're good. Is that right? That is not right at all. How did I even get 123? This is, what is this? Oh, because I have this thing still there. Silly Larry. Alright, I mean still wrong, but at least it's not impossibly confusingly so. Okay, so this is after 0 iterations, right? So that should be right. After 1 iteration, okay. Oh, after 1 iteration, so it's 1 and 2, okay, but then what's the best? I mean, we have 40 minutes, we should be able to do this. I mean, I guess that's why how people got it, but I am just messing up on the indexing, I think. Possibly, maybe worse. Okay, so what's 0.5? 0.5 is the max of all of these, right? So 0, that means that this is wrong. Why is 0.5 wrong? 0.5 should be best of 0.4. Oh, there's another one, right? So it's best of, so then it's j plus 1, j plus I also. I think that's probably good too. Okay. Is this, I mean, it's right for the input, but is that the right answer, right? I don't know. This looks reasonable though, I think. All right, just YOLO. I mean, I don't know if this is quite right, but ooh, no, remove the print statements, Larry. Don't get the wrong answer for that. All right, I mean, at least we got the input, so let's give it YOLO. And there's no real reason why this should be, you know, okay, good. There's no real reason why like we should accidentally get the right answer for the input, is what I was gonna say. That was a tough one though, but I think I actually just misread this for a little bit, but but I just misunderstood the problem and I analyzed it in a different way, but I think ultimately it is a fun one. It's a fun one for sure. I didn't get top 25. And maybe I end up 37th or so. Times 2 for China. Okay. I mean, not like hitting it out of the ballpark, but doing pretty okay. 5 minutes though. I mean, knowing the answer, I could see how it can be done in 5 minutes, but the analysis is tricky. Actually, I mean, this is why you grind it out, right? Like, I just misread this for the longest time. I always had this idea in the back of my head. You can actually do, as I was saying, but you don't need to because it's n squared, right? So, yeah, and I missed this part. And it's a good, I guess, like, if I didn't have this, that would have been very tricky. Just because, it's just very tricky to get it right if that maybe not, it just would have cost me one wrong answer. So 4,006 seconds or 4.6 seconds. I'm just gonna write some just small optimizations. Someone told me that there's a cleaner way to write this, so that, but I don't know. Let me know in the comments. There probably is. I feel like I've seen it before, but oops, that's not right. That didn't make sense. There probably is, but I don't know. I feel like let's give it a quick YOLO submit just to see. It should be a little bit faster. Combination is kind of wrong phrase, but it's probably fine. This is actually slower. I don't know what to say, but I mean, this is as fast as it gets, really, right? So I don't know how. I mean, as fast as it gets for n squared. And I don't know that you can do this part faster than n squared, so this is just if statement, so I don't even think it is, that much better. And this is just lookup, so I definitely does not definitely doesn't matter that much, but yeah. But alright, I mean, I did okay. 93 people got it, so we'll see how like I said, I did okay. I mean, I think the visualization did help though. I took it out, I suppose, but and it's a very good because it. I mean, the visualization itself didn't change anything, but it empowered me to be like, okay, what does it mean? And I was trying to think about it in terms of the scope of everything else, right? So as a result, then I was able to construct this matrix, and this matrix I was able to construct the rest. The rest is straightforward. I just have to think about the right indexing, which is easier said than done, as people know. 4 by 1s definitely got beaten by 40 minutes is insane. People are so smart. But yeah, all right. That's all I have for this one. I mean, clean sheet, no wrong answer today, and this contest ended bi-weekly, so I'm happy about that. That's all I have. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye. Oop, find the button.